One other concept that is very important to this discussion is that of state functions. And what a state function is it's a change in something that changes where it only depends upon the initial and the final state of whatever's being changed, and not upon the path or method by which it's getting from that initial to final state. Internal energy is a state function. Okay, so it only depends on where the final, initial and final state it is. It doesn't matter how you actually get there. And so if we consider these two different examples here, or excuse me, consider this beaker right here. It's 50 grams of water. It's at 25 degrees Celsius. And so if we were to consider two different methods from getting there, say we had a beaker that was hot, okay, 50 grams of water, 100 degrees Celsius, and we cooled that. We could get eventually to this point where we have 50 grams of water at 25 degrees Celsius. Or if alternatively we had a beaker of water at 0 degrees Celsius, which would have probably some ice in it, and we heated it, we could eventually get to that water being at 25 degrees Celsius. It would still have 50 grams in it. The point is that the internal energy for either one of these beakers, the one that results from going this direction, or the one that results from going that direction, would be at the same place. That internal energy would be at the same position. And so it doesn't matter which direction it goes. It only matters what that final result is. A really analogous situation, something that many of you would have experience with, is transferring money from an account. The actual value of your account, however much money you have in that account, is a state function. Doesn't matter if you consider these two examples here. Say you had $50 in an account, okay, and then you spent $25 of that. The value for the account afterwards would be $25. Now consider if you had an account that had zero money in it, and you got a check for $25 and you deposited it into that account. The value of the account afterwards would still be $25, even though two very different paths were taken to get it to that. So internal energy is a state function, but heat and work are not state functions. Okay, so these are actually very dependent upon, well, if there's heat or work being done, those are not state functions. And so an example of where this would be these concepts would be very important is if we were considering the charge on a battery. Okay, so say we started with two batteries, and the batteries had equal charges on them, and then they got from this point all the way down to the discharged value. Okay, so the charge on the battery is here, and then the end point is here where they're completely discharged. That has a particular change in energy. Now consider the two methods that are these two different methods that could have been used for discharging this battery. If you run a current through this right here is representing a resistor. If you run a current through anything that has resistance in it, which is pretty much everything, some stuff has a lot more resistance than others, and you keep discharging this current, you keep discharging that battery, eventually you'll end up with a battery that is completely drained. All of the energy that was transferred out of the battery, which is our system, was transferred as work. So because we're moving electrons through here, okay, the movement of electrons through here actually heats up this resistor, and so that's where the energy loss from our system is. In this case, we are actually moving electrons through here, but these electrons are actually propelling this fan. And so when those electrons propel the fan, you actually get a lot of work being done, the movement of the fan. Now, no process is 100% efficient, and so there's always some sort of heat loss that occurs for any of this situations. There are some resistors in the fan itself, and so when you have, again, electrons going through a resistor, there's some heat generated, and that heat is lost to the surroundings. In both cases, however, we have a discharged battery. The change in energy is a state function because it's at one position here and another position here, but the paths we took are two very different paths, and these are not state functions. These are very dependent upon the paths you take, both Q and W.